Hi, this is just a quick video because I wanted to go through the quizzes that you had last week. We had a wide variety of scores on those, and I just want to make sure everybody does get what you're supposed to do with those quizzes. So the first part you had dealt with sample size, and you were using one of two formulas to get most of your answers, plus a table that you could use to find z-values. The very first question asked you which piece of information didn't you need to know for this? What's not a part of the formula? Well, in the formula, it asks you for a z-score that goes with a level of confidence. So we had to know 95% confidence. It asks you for a standard deviation, so we need to know the standard deviation's 14. And it asks you for the margin of error. And here it tells us that we want to estimate things within 5 minutes. So all of those are important, but what you don't need to know is the average. And so the average is 43 minutes is the unnecessary piece of information. Next question asks you what is the margin of error, and I already told you it was 5, but the dead giveaway for that is always the word within. So 5 minutes, within 5 minutes is the margin of error. It asks you the z-score that we're going to use for this problem, and since it says 95% confidence, I go up to that table at the top, and the z-score that goes with it is 1.96. Then we need to actually crank out the formula. And there are two things that sometimes go wrong when people are doing this, and the wrong answers include both of those things that go wrong. One of them is that people forget to square, and you do need to always square to come up with your answer. The other thing, and it's what a lot of you did, not just on this problem, but on a whole bunch of problems through here, is that on sample size problems, you always round up. And that means that even if I get 30.1, where normally in math you'd round down, you always round up for sample size problems. The idea behind that is that if I just had 30, it wouldn't be quite enough to get the results I want, but if I have 31, it's going to be more than enough. Now, there are several of you that did this like 3 times, and that is why it ended up just being minus a half for each of those instead of minus 1. And as long as you get that idea that, yeah, it is always rounding up and you got the mistake, that's really the key thing on here. So then you have some other sample size problems. And on the next one, again, I'm just plugging the numbers we know. The z-score this time is 2.33. The standard deviation, 7.3. We want it within 3 minutes. And again, you square that. And just like before, we have to round up, so it's 33. The other two problems on that first quiz both dealt with percentages. And the formula for percent says p hat times q hat times the quantity zc over e squared. Now, a couple of things with this. The P is basically the percent that's given in the problem. 9% of Americans use Twitter every day is what that is. What the Q hat is just the opposite of that. If 9% do use Twitter daily, then 91% don't. And so you just always have opposites that add up to 100 in those. The ZC you look up in the table just like before. And here it's 1.96 over 0.04, which again is within 4%. Your percents are always written as decimals in these problems. And you do square the parentheses, but not the beginning part. This time you probably got it right no matter what because you do round up. And so it is going to be 197. Last one on this page is another one where you might have missed it because you didn't round up. And the important thing on this one, though, is that if you don't know ahead of time, you assume it's 50-50, so 0.5 times 0.5, look up the z-score, 1.645 over 0.02 squared. And again, you get 1691 and some change, but you got to round up to 1692. The second quiz that you had dealt with hypothesis testing, and in particular with one proportion z-tests. First question is just reviewing something we did clear back at the beginning of the semester. It says the goal is to see if results are significant. What does significant mean? Well, it means it didn't happen by chance. The variable for level of significance is alpha. Here that's choice B that looks kind of like a fish shape. And the true-false question is actually kind of an important one. It says true or false, the more important the topic you're researching is, the lower your value of significance. That is true because the level of significance is basically the probability you're wrong. And if you have important research, you don't want to be wrong very often, so you want that number to be low. Next one asks you about hypotheses. And the last part of the problem, it says, does this indicate that the population proportion of extroverts among college students is less than 82%? Well, you're supposed to look at the statement, the proportion is less than 82%. The one that you get by just basically copying the problem is always the alternative hypothesis, the H1, so it is the first choice. The null hypothesis would have said it's not less than 82%. It asks you which number in the problem 56 would be, what variable is that? Well, it's 56 out of 73 that were extroverts, and the smaller of those numbers is always x, the larger of the numbers would be n. So here it is x that's 56. And the P0 is the 82%, the n would end up being the 73. Goes on to ask you, should you highlight not equal, less than, or greater than in your calculator? Since the question says that the percentage is less than 82%, that's why you highlight less than. And there were two more quick questions on here. It asked you to calculate the p-value, and just to remind you what you do with that, you go into stat tests. You want to choose one proportion z test, and in this whole chapter it is test rather than interval you're going to choose. You put in all the numbers we were just talking about and make sure less than's highlighted. And when you get the readout screen, the thing you want is the line that just says P. It's right below Z, and it says 0.1198108194. Now, I basically accepted that rounded to pretty much any number of decimal places you wanted to do. There was at least one person that put something like P equals 0.1198, and I did go back and count that right. I've mentioned before that I do see the numbers that you submit when you do take your quizzes, and so I do go back and look at them if there's a problem and try and catch things. But yeah, here it's going to be about 12% or 0.1198. Pretty much any hypothesis test, the final question boils down to yes or no, is this significant? In another stat class you might end up in later on, they might ask you the question like, can you reject the null hypothesis? It's the same question, it's just phrased differently. But the answer on this one is no. And again, what I do with that is I look at my p-value, and I go back to the problem and I look at alpha, the level of significance. And in order to say that yes, it's significant, my p-value has to be less than alpha. Here it would have had to have been less than 1%, and it's nowhere even close to that, so it's definitely going to be a no. Again, we had a variety of scores on the tests last week. This week, you're going to be doing some more hypothesis tests, and hopefully, especially going through that second quiz, does make it a little bit easier for how things work with those.